All right, today we're going to start looking at some more probability. We're going to look at this idea of random variables. A random variable is a numerical outcome of some chance process. It's when the variable will take on different types or different numerical values, such as 0, 1, 2, 3, 4, or whatever the case is. There are two different types of random variables that we're going to be concerned with. So again, we're looking at probability, but somewhat of a different than what we did in chapter 5, where we just looked at the straight probability rules. And the probability rules will always apply. So in random variables, there are two types of random variables. There's what we are going to call a discrete random variable and a continuous random variable. A discrete random variable takes a countable number of outcomes. There's a finite amount of things that can happen. And in a continuous random variable, there is an infinite amount of outcomes. So, what is a random variable? It just takes on numerical values. It describes the outcomes of some sort of chance process. And to describe a random variable, first we will make a probability distribution. A probability distribution gives, whoa, I'm throwing my pen everywhere, gives all the values of X and the probability of that value. So these would be all of our X values, and these would be the probabilities that correspond to those values. So in this case, we have a short little probability distribution. All the values of X, X can take the numbers 0, 1, 0, 1, 2, or 3. And the probability that 0 shows up is 1/8, 3/8, 3/8, and 1/8. And I know most of you guys prefer decimals over fractions. So we could write this as 0.125, 0.375, 0.375, 0.125. It doesn't have to be in fractions, but oftentimes it's easier to deal with if the probabilities are listed in fractions, especially if they're simple fractions, such as this. Well, this is an example of looking at you having 3 children. If you had 3 children, what is the probability of having 0 girls, 1 girl, 2 girls, or 3 girls? So to find or to make this probability distribution, we would probably be easiest for us to go back and look at a tree diagram. So for example, we're going to have kids, okay? And my first kid could be a boy or a girl. Now we're assuming that children are equally likely, that the probability of having a boy and probability of having a girl are the same. So these probabilities would be 1/2, 1/2. Now remember in a tree diagram that the second branch that comes off is really a conditional probability. So given that my first child was a boy, what is the probability that my next child was a boy? Well, it's still 1/2 because these events are independent. It doesn't matter what my first child is for the probability of my second. So given my first child was a boy, what's the probability my second child is a girl? Well, it's still 1/2. And that idea is going to continue throughout the process. So here we are having 3 children. I could have boy, boy, boy. I could have boy, girl. I could have girl, boy, girl, girl. Well, what if my first 2 children are boys? What could happen on the third? Well, you know what? Again, I could have a boy or a girl, boy or a girl, boy or a girl, boy or girl. And all of these probabilities are 1/2 all the way down once again. So to find my sample space or the list of all possible outcomes, I could have triple boy, I could have double boy girl, I could have that takes care of these two. I could have boy girl boy or boy double girl, or I could have a girl first and then a pair of boys, or a girl, a boy, and a girl, or girl, girl, boy, or triple girl. So the probability, this first one up here would be having 0 girls. Well, that probability would be 1/8 because it would be a half times a half times a half. So that's where this 1/8 comes from right here. The probability of having 0 girls. Well, what's the probability of having 1 girl? Well, I could have 1 girl here, or I could have one girl here, or I could have one girl here. So that would be 1/8 plus 1/8 plus 1/8, and that's where the 3/8 comes from. And this process continues for all of our possible outcomes. Again, this example is looking at the probable or the random variable X in question is the number of girls out of 3 children. And the corresponding probabilities are put underneath here. So X, the random variable, and the probability that X occurs. This is our probability distribution, and we're going to want to make one of these for every problem. Oftentimes, the probability distribution will already be made for us. But if not, a tree diagram is a very good way for us to build the probability distribution. Okay? And as mentioned before, there are 2 different types of random variables. There is a discrete random variable, which takes a set number of outcomes. There is a fixed number of outcomes. And as the definition states here, with gaps in between them. So in this case, I could not have 1.5 girls. Either I have a girl or I don't. It doesn't make sense for there to be any values in between here. Either I have the kid or I don't have the kid. So this would be a discrete random variable because there is a countable number of outcomes. There's only 4 different things that can happen if my random variable is the number of girls out of 3 children. So just like before, the rules of probability must apply. Every single probability has to be a number between 0 and 1. And the sum of all the probabilities has to equal 1. So as you can see here, 1/8 plus 3/8 plus 3/8 plus 1/8 equals 1. And each individual probability is a number between 0 and 1. So, now, if we have a discrete random variable, we need to describe the distribution of this discrete random variable. We looked at the tree diagram and how we come up with this. Well, let's look at what this distribution would look like. So this would be number of girls. And what are the outcomes? 0, 1, 2, 3. And I could have, the probability is 1/8 for 0. For 1, oh, well, this isn't going to work so good because I made this too skinny, but let me erase that. So I could have 0, 1, 2, or 3. The probability of 0 girls is 1/8. The probability of 1 girl is 3/8. The probability of 2 girls is 3/8. And the probability of 3 girls is 1/8. So I can look at this distribution and say, oh yeah, it is symmetrical. It has a center of about 1.5. I could talk about its spread and all of that other good stuff. So just like before, when we meet a distribution, we need to talk about 3 things: shape, center, spread. Well, looking at the histogram that corresponds to this probability distribution of having girls out of 3 children, you can see from my histogram what it looks like. Well, how do I actually calculate the mean of a discrete random variable? Well, they've done put some formulas together for us here, which look very scary and confusing, but once we dive into it, you're going to see that it's really not all that bad. The mean, or we're going to talk about expected value. Anytime you hear the word expected, you need to automatically think mean. What does expected mean? It means find the mean, find the center, find the mean. Expected means mean. Expected means mean. Well, how do I find the mean of a discrete random variable? Well, you take every single X value and you multiply it by its probability. So let's look at the previous example for the number of girls out of 3 children. If you remember, our probability distribution was 0, 1, 2, 3, 1/8, 3/8, 3/8, and 1/8. Now, how would I find the mean of this random variable X? Or oftentimes they'll write it E of X, meaning expected value. The mean means expected. So I take each individual value, 0, times its probability, 1/8, plus 1, times its probability of 3/8 plus 2 times its probability of 3/8 plus 3 times its probability of 1/8. So this is 0 plus 3/8 plus 6/8 plus 3/8. Well, if I add that all together, I get 12/8, or 1 1/2, or for all of you decimal lovers, 1.5. So the mean, the expected number of girls I'm going to have out of 3 children is 1.5. Now, I know that doesn't make sense. It's impossible to have 1.5 girls. However, the mean, or the expected value, is telling me the average over the long run. If I had 3 children over and over and over and over and over again, that on average, I would have 1.5 girls out of every 3 children that I have, which makes sense since the probability of having a girl was 1/2. So half of 3 is 1.5. So in this case, it's a pretty simple example, and it seems to make common sense as to why the answer would be what it is. All right. Now, you can see this beautiful formula right here. So the expected value, or the mean, of a discrete random variable says take each value x times its probability plus the next value of x times its probability plus the next value of x times its probability until we've done that every single time. Or, as you will see in your formula packet, which you'll be able to use on every test, every quiz, as well as the AP exam, they're going to write it this way: the summation of x sub I times p sub I, which says take every individual x times its probability. And then this big summation symbol here says add them all together. So there's an example or a problem here for you on the right. We define the random variable x to be your APGAR score, which is a score that they give to a newborn baby. If I want to find the mean of this, I have to take 0 times 0.01, 1 times 0.06, 2 times 0.07, 3 times 0.08, and so on, and then add them all together. That kind of sucks. It's a lot of work and it's very time consuming. So let's take a look at our having girls problem, and let's use our calculator to do all the heavy lifting for us. So let me grab our calculator here. So if I want to find the mean of this random variable x, which I've done and the work all over in here, let's look at using our calculator to do that. Remember, our lists are going to be our best friend. If we can learn to manipulate this list, everything is going to be so much easier for us. So again, to find lists, you can go into lists. I like to go to stat edit. I like the stat button in here because it's stats class. Makes sense. So I go into stat edit. Whoops, I got a bunch of stuff in list 1. Let me clear that out. Remember, again, to clear a list, make sure you go up to the top and you highlight the list. You can see that the L1 is bold. And then I hit clear and arrow down, and that list is gone. So I'm going to put all of my X values in list 1. So I could have had 0 girls, I could have had 1 girl, I could have had 2 girls, or I could have had 3 girls. Now, in list 2, I'm going to put the corresponding probabilities. So X1 was 0. What was the probability of having 0 girls? Oh, that was 1/8. So I can put in 0.125, or I could also put it in as a fraction, 1 divided by 8, and it will churn into a decimal form. And the probability of having 1 girl was 0.375. The probability of having 2 girls was also 0.375. And the probability of having 3 girls was 0.125. Now that I have all of this entered, I'm going to let the calculator do all the work for me. So what did I do to find the mean of a discrete random variable? I took each individual x, 0, times its probability, 1/8. The next x times its probability, and so on and so on. So let's have the calculator do all this multiplication for us. So I'm going to go up to the top, and you cannot be highlighted in the cell or it won't work. You can't put a formula in a cell. You have to put it on the list heading. So you can see L3 is bolded out again. I'm going to put in the formula. So what do I want the calculator to do for me? I want L1, which is second 1, times L2, which is second 2. That's going to give me all of these answers: 0, 0, 3/8, 6/8, 3/8. Well, I'd kind of like the calculator to do the rest of the work for me. I'd like it to add it all together for me. So if I go back to my main screen and quit out of my list, so I went second quit to get out of the list, I'm going to have the calculator add up list 3 for me. For me, the easiest way to find the sum is to go to catalog, which is second, 0, and then I want it to do sum. So if you look at the green letters there, I'm going to go to T, and then I'm going to scroll up until I find sum. Oh, sum. I hit enter and it comes up on my main screen. Calculator's like, cool. Sum, I'm going to add some stuff for you. What do you want me to add? Oh, would you please add all of the values in list 3? 1.5. That's the mean that we calculated when we did the work over here. So 1.5 was the mean. By putting it in the list, let the calculator do all the work, and we won't have to worry about all this chicken scratch over here. So that's how we would use the calculator to find the mean or expected value of a discrete random variable. Remember, once again, a discrete random variable has a countable number of outcomes. And as you can see in this example over here, if there were 10 values, 0 through 10, this would be painful to do by hand, write all these numbers down and then go type them back in and add them up. So by being able to manipulate your list, it's going to make this process much, much easier. Your lists are your friends. Get comfortable with them as soon as possible.